Today I am going to show you that solids take up space. You can see I have put one bead on the pipe cleaner. The more the beads you put on, the less space you have on the pipe cleaner. If you put on a lot of beads, then you won't have any space left on the pipe cleaner. Solids are all around you. This table is a solid, these beads are a solid, this pipe cleaner is a solid. You can see I have taken up a lot of space on the pipe cleaner. This is showing that solids, like a bead, take up space. Today, I will show you that liquids take up space. I will use grape juice and a cup. You can see that the grape juice has filled up the cup, and there is only a bit of space left here at the top. This is proving that liquids take up space. And once you drink the liquid, it takes up space inside of you. This is proving that liquids really do take up the space. We've shown liquids take up space and solids take up space. But we haven't shown the last thing of matter that takes up space. Can you guess what it is? It's gas. Like in a balloon. Gas. Liquids, solids, and gas all take up space. And they are all part of matter. Gases is air, oxygen, smoke. Gas is a lot of things. And when you blow a balloon, you're blowing gases to it. Today I will be measuring peanuts to show you can measure solids. Caitlin, please hand me the measuring cups. I will be using a 1/2 of a cup and a 1/4 of a cup. First I will do the 1/2.
Peanuts. Don't forget about the peanut part.
This is 1/2 cup peanuts. This is 1/4 cup peanuts. You can measure solids with cups,
Peanuts.
or maybe a ruler. Today I will be showing that you can measure water with my assistant, Caitlin. Caitlin, please hand me the cup of water. I have measured water to about 1 cup. You can use any measuring cup. We have used a cup that goes up to 2 cups. Today, I will measure air using a method called displacement. Caitlin, please hand me the balloon. I will push the balloon down in the jug of water filled to 3 cups. The balloon is filled with air. When I push it down, it goes to 5 cups. This means there are 2 cups of air inside the balloon. This is what happens to water when it gets heated. It turns into a gas. You can kind of see it steaming. Right there, and right there. Today, I will be seeing who is a better insulator, wood spoons or metal spoons. Caitlin has the 2 spoons. Please hand me the spoons. I will put them in the water. Whichever one gets warmer first is the worst insulator. I will be using a food thermometer to see which one is a better insulator. The wood spoon gets up to about 80. The metal spoon gets up to about 180. The wood spoon is a better insulator because it stayed cold longer. I'm doing an experiment to see if wool or cotton is a better insulator. I will put this ice pack on my chest to see which one it gets colder faster. My dad will time me. Okay, it's getting really cold. The cotton one is getting really cold, and it was super fast. It was 10 seconds. This is the wool sweater. Now I will test the wool. Okay, it's starting to get cold. Let's see how much. It was 20 seconds with the wool and 10 seconds with the cotton. The wool is a better insulator than the cotton. Today, we will be turning liquids into solids by making popsicles. Please hand me the cranberry juice, Caitlin. Yes. I will pour the cranberry juice into 2 of them.
That's not good. Stop. Oh my goodness.
Caitlin, go get a rag. Now I will pour the grape juice in.
Okay, that's good. Can you help me, Daddy? Hey, it's getting this. Yeah,
Careful!
I am.
Now we will put the lids on the popsicles.
You do those ones. I'll do these.
Oh my goodness.
Oh my goodness.
I think we have another bit of mess, Caitlin. Now I will go put them in the freezer. I'm gonna check the freezer now to see what the juice did. The juice turned to a solid, from a liquid to a solid. It is now a popsicle. This is a piece of ice. It is a solid. When it starts to melt like it has, it turns into a liquid. And that is how a solid turns into a liquid. When the gas turns back down into a liquid, it gets more particles. That is how a gas forms into a liquid. Today I'm going to make heat without using a fire. When you rub your hands together, it causes friction. The more you rub your hands together, the more friction you get, which causes heat. I just put a magnifying glass up to my hand that was put up to the sun. That shows that you can project heat without fire.